Hi everyone, this is Shikha Gurjar. I work for Guidewire Software. I'm a project manager there. I've been with Guidewire. I've been working in the property and casualty industry for the last 10 years. And today I'm here to talk about how observable identity systems have transformed. These cloud based identity systems today let you see exactly what's happening during identity checks. And they do this by using smart checking of the biometrics. Maybe it's fingerprinting, facial recognition, or voice recognition. There's also AI involved that analyzes the process to identify any issues and improvements. And then we have blockchain technology to ensure everything is transparent and it's secure. The observable systems help the team identify issues much more quickly, and that reduces the time taken to identify a problem by 87%. That means the systems have less downtime, we have quicker resolution and response, and we have better user experience, which adds to system reliability and resilience. So observable identity systems give real-time insight into the entire verification process. At the core, these systems use instrumentation, meaning they capture important data points as users go through the verification journey. This could include biometrics, system response time, or error patterns. And all this data is then fed into the monitoring and alerting tools that help teams detect issues like a failed verification or a suspicious login. And we can record it, we can get to know about this in real time rather than waiting for hours and getting to know it about hours or days later. And we don't stop there. There's also a technical layer involved. These systems also translate that raw data into meaningful business insights to help insurers make smart decisions around security, process improvements, and customer experience. For example, let's say insurers can use this information to spot security risks early on. It helps us to optimize, it helps an insurance company to optimize the customer journey by removing bottlenecks. It also justifies investments in better tools or infrastructure based on hard data. In short, we can definitely say that the observability turns what used to be a black box into a clear, process driven, data driven process that improves customer experience. This modern observability has taken fraud detection to a really next level. Unlike traditional monitoring, these systems can now detect even sophisticated spoofing attacks like fake IDs or deepfakes with a 99.99% accuracy, and they do it in real time. This is a huge leap forward, giving businesses, including insurance companies, a much stronger protection against fraud and reducing the time it takes to respond to threats. Moving on to operational improvements to observability. Observable identity systems don't just improve security, but they also offer a lot of operational benefits. By giving teams deep visibility into system performance, they help spot and fix issues before it affects customers. And this includes capabilities like transaction tracing, which helps identify failure early on and helps to understand why the slowdowns are happening. It also helps in capacity planning to anticipate and prepare for usage spikes, and also supports continuous improvement by turning system data into actionable insights. And in short, they help operations run smoother, faster, and more in a more proactive fashion. Distributed tracing lets a user track a single request as it moves through the web services, multiple microservices involved in the verification process. And this helps one understand how each part of the system is performing and where delays or failures are occurring. Let's go through an example here. Let's go through an identity verification example here. Imagine a user is going through an online identity verification process. Here's how distributed tracing works across the different microservices involved. First, they'll use a document upload service. So the user uploads the ID document, and tracing captures how long the document took and whether the files were successfully received or there were any errors. If there were errors, it also captures the logs. Then we use the document verification validation service. The document is now scanned for authenticity, expiration, and tampering. At this step, the tracing shows if the validation passed or failed and how much processing it took. Then we use the biometric matching service. Here, the user takes a selfie for face match, and tracing logs the image capture, comparison time, and the confidence score of the match. The first service is the data verification service. The personal info is verified against a third party sources. For example, it could be government databases, it could be credit bureaus, etc. Here, the tracing records each external call and how long they took, helping spot third party delays. Last but not the least is the risk assessment engine, and all the results are fed into a risk engine that calculates a trust score. Here, tracing shows how data flowed in, how rules were applied, and if any step triggered a risk flag. Now, you must be wondering this. It matters because with distributed tracing, we can pinpoint slow services. Let's say if the biometric matching is consistently lagging, it can help us identify that. It can also spot failures early on. For example, if the document validation service is crashing intermittently, it will help us to identify that. It also helps improve performance and also deliver a smoother customer experience by solving issues before users are impacted by it. Moving on to the advanced correlation techniques for identity events. Advanced correlation techniques help connect related events across different identity verification steps, turning individual data points into a clear, actionable story. Let's take a real world example. Let's say a user is going through verification. The document scan is successful, the biometric match is slightly off, and the database check returns inconsistent data. Alone, each event might seem fine, but or just slightly unusual. But when correlated or connected together, they could indicate a spoofing attempt or an identity fraud. So, how it works? Correlation engine connects events from across the system, document scanning, biometrics checks, backend validations, etc. Using machine learning, they build normal behavioral patterns. For example, time taken, device type, and match scores. When patterns deviate, even slightly, the system flags it early for review. Why it matters? It helps detect complex fraud patterns that would be invisible if each component were reviewed in isolation. It reduces false positives by understanding context, enables proactive action, stopping problems before they escalate or affect users. There's also behavioral based anomaly detection. So behavioral based anomaly detection is about spotting unusual user behavior that could signal fraud or security threats, even when credentials are correct. How it works. First, we establish the behavioral baselines. The system learns what normal looks like for each user or a group, such as typical login times, usual devices, locations, common, common pattern in document uploads, and biometric processes. Then we apply machine learning tools to it. These tools monitor user activity in real time and compare it to the established baseline, looking for subtle deviations. Faster than normal form fills, did failed biometric attempts, logins from unusual locations and devices. After that, we calculate the risk scores. Each action is scored based on how risky it seems. The more behavior deviates from the norm, the higher the risk score. Then we'll trigger adaptive authentication based on the risk scores. So the risk scores cross a certain threshold, the system can ask for additional verification, like an OTP, flag the session for manual review, or block the action entirely if it looks too risky. Why it matters? Because behavioral based detection goes beyond static rules or password checks. It helps catch sophisticated attacks by focusing on how users behave and not just what credentials they use. But with all this behavioral information which we capture, we also need to take care of the privacy. So, implementing observable identity systems means walking a fine line between comprehensive monitoring and user privacy protection. The key points here, which we need to take care of, is the comprehensive monitoring needs to ensure strong security and smooth operations. System need to capture detailed telemetry. like user activity, system performance, and authentication behavior. We need to take into account privacy considerations. However, this data often includes sensitive user information to limit what's collected to only what's necessary and anonymize or encrypt personal data. We need to have a balanced approach. The goal is to find the right balance, enabling visibility for fraud detection and troubleshooting without overstepping privacy businesses. This includes being transparent about what data is collected, providing controls and opt outs where applicable, and designing systems with privacy by default. If we can say, a successful identity observability strategy should deliver security and insight while also earning user trust through responsible data practices. Now, let's talk about the roadmap for the implementation of these verification systems. Implementing an observable identity systems is a phased journey. It's just not a one time setup, it evolves across 5 key stages. First is the assessment stage. We start by evaluating the current capabilities. What telemetry is already being collected? Where are the blind spots in identity verification? And are there any tools and gaps in monitoring? The idea here is to establish a clear baseline and identify quick wins. The next will be the instrumentation. Now we add instrumentation to capture detailed data across identity workflows. For example, document upload, biometric match, third party verification, and risk scoring. We need to make sure we make all steps traceable with real time data points. Then we do the integration. We introduce automated alerts and adaptive responses. High risk behavior triggers setup authentication. System errors notify relevant teams instantly. The idea is to reduce manual intervention and improve response times. It's the refinement step. We need to continuously improve, and we can do that by tuning machine learning models for behavioral based detection, updating baselines as user behavior evolves, and expanding visibility to new components or channels. The goal here is to optimize accuracy, reduce false positives, and support scalability. The full implementation can take anytime between 6 months to 12 months, but if we try the incremental approach, we can start getting start utilizing the benefits within 2 to 3. The key takeaways and next steps. The first is the measurable benefits. 87% reduction in mean time to detection shows real power of observable systems. Enhanced data detection accuracy through advanced techniques like behavioral analysis and event correlation. Operational gains through transaction tracing, capacity planning, and continuous improvement. Transforms raw telemetry into business intelligence to better security and process decisions. We need to make sure that we have a right balance, privacy balance. Effective observability requires a careful balance between monitoring and data production. Systems be aligned by privacy with privacy by default, respecting user data while ensuring security. Anonymization, transparency, and regulatory compliance are non negotiable pillars. We need to use a holistic approach. We need to combine instrumentation, monitoring, machine learning based analytics, and adaptive authentication across the identity lifecycle. We need to support distributed tracing across microservices. The journey, we need to have a strategic journey. Implementation is phased, begins with assessment that moves to instrumentation, integration, automation, refinement. The full rollout takes 6 to 12 months, but we can see the benefits within 2 to 3 months itself if we use the incremental approach. Thanks everyone for that's all I had for today. Thanks everyone for listening to this presentation.